so keep an eye out for those. Our next speaker is a senior front-end engineer and has built production applications at scale in organizations like DoorDash, Instacart, and Shopify. He's also a published author and a course instructor who's helped thousands of students learn React, Vue, TypeScript, and GraphQL. Please welcome to the stage Hassan Djirdeh.
Hello, everyone. My name is Hassan, as mentioned, and today I'm going to be giving a talk on React and TypeScript patterns. That was a really pretty brief intro about me, so I won't spend too much time talking about myself again. I'm currently at DoorDash. I'm part of the experimentation platform team, helping build the experimentation tools that other people at DoorDash use. And prior to DoorDash, I worked at Instacart, Shopify, and Deloitte. And I graduated from the University of Toronto, in which the campus we're at today, we're at right now. Cool. The last talk I gave was at Web Unleashed 2019. That was just before the pandemic kicked off. And the very first talk I gave was at Spotlight Vue, which is also part of the people who manage this conference, FITC. So I'm a little rusty today, bear with me. But I think I'll get back into the groove. OK, so we're going to talk about React and TypeScript. I don't intend this talk to be very complicated or advanced. If you've used React and TypeScript before, some of the things we talk about today would be pretty straightforward. But if you've used React and haven't really dived into TypeScript, hopefully this talk is perfect for you. I like to usually quickly explain things, assuming not everyone knows what we're using. React, most people I think will know what that is today. It's a library essentially set to build a web and native applications. And one of the core aspects of React is the capability to build components. This is a still from the React documentation. And essentially, React apps are built with building blocks known as components, where every component has its own HTML, JavaScript, CSS. TypeScript, on the other hand, is a typed extension of JavaScript. If you've used JavaScript before, you know you can just simply assign certain data types to variables. And somewhere else in your code, you can just simply reassign a different data type to that variable. JavaScript doesn't complain. And a big reason to that is JavaScript is a dynamically typed language. This allows us to move a bit faster, but however, this can sometimes be a source of bugs or issues. And we only notice this issue during runtime, when we actually run our application. TypeScript gives us a bit of a capability to say, you know what, we want to specify actual static types for our variables. So perhaps if we say, a variable is a number, somewhere else in our app, if we just actually try to reassign this data type, TypeScript will give us a warning or an error that tells us, in this context, a string is not assignable to a number. And we catch this error during the compilation process, when TypeScript is being compiled down to JavaScript. This leads to a better developer experience. We catch errors and bugs during compile time, as opposed to runtime. This leads to a better and easier maintenance, especially as an application grows much larger in scale. And it even leads to better collaboration at times, because TypeScript has a really nice self-documenting nature to it. OK, I went pretty quick there, and now I'll try to go a bit slower, and now try to discuss how TypeScript plays pretty well with React. And in the next few sections of the presentation, I'm going to focus on essentially talking about different concepts or patterns that you often do when working with React and TypeScript apps. And we'll start off pretty simple at first. Typed props. As mentioned earlier, React gives us the capability to build our UI with components. Components, today, for the most part, are just functions that receive data or props, and we're able to render this information in our template. Here, for example, we have a person component that receives a name prop and an age prop. And we just simply render this information in this particular component's template. Somewhere else in our app, we can just simply render this component, and we can provide values that we want this component to render. So perhaps we want name to be Hassan, and we want age to be a number 30. However, if we intend to render this component elsewhere, we can see that we can provide any data types to these props. We can provide a Boolean, an array of numbers, so forth and so on. And just like how we mentioned in normal native JavaScript, we can just simply pass in or specify changes in data types. If we're working in React in a native JavaScript setting, we can just specify whatever types we want to our props. TypeScript can give us a bit of an advantage here. We can tell our actual component that we want certain shapes for the props we pass in. So we can essentially perhaps build up an interface or a type, and we can say that this particular component should receive a string for the name and a number for the age. We make sure to specify or assign the props we pass in to have the shape of props. And now elsewhere in our code, if we intend to render this component and we pass incorrect types, we get the benefits of TypeScript during the compilation process and during development. We're essentially told type Boolean here, for example, isn't assignable to a string, and an array of numbers isn't really assignable to a number. Okay, let's quickly move on to another straightforward or simple concept within React, and that is React hooks. Hooks in React essentially allow us to share and encapsulate stateful logic between components. We can build our own custom hooks to leverage this, but React comes predefined with a set of default hooks, with the most common or the most straightforward to use from the beginning being the use state hook. State in React is essentially the concept that allows us to manage how the UI deals with data within components. If a React state property changes, React re-renders to reflect that change. And with a functional component setting, we can use the use state hook to achieve this. So here, as an example, we can pass in the value of Hassan as a state property we want to create. And the use state hook essentially gives us two values. The state property itself, here we're just saying name as an example, and the set name function. TypeScript allows us to take this a bit of a step further. Not only can we pass in the initial value into our hook, we can also pass in the type variable that we want to specify that this state should be. So perhaps here we can say that we want to ensure that we want to create a string state property. Whenever we use the state property anywhere else in our components, with TypeScript, we'll recognize that this is a string, and the setName function would recognize that it's going to receive an updated value, which is also to be a string. And this pretty much exists through practically all the main hooks that exist within the React library, like the useContext hook. UseContext allows us to create contextual data or data that can be accessed by components nested within multiple trees. So here, for example, assume we wanted to create some context within our app that's going to represent the theme of an app. Light theme, dark theme. We can have the createContext function to essentially receive this initial value. And somewhere else in our components, we can simply use the useContext hook, receive the theme state property. TypeScript, again, allows us to be a little bit more specific in what kind of theme we're creating in this example. So here we can perhaps say that we want the theme to only be light and dark, and we pass it in as a type variable into the createContext function. And now anywhere we use the theme in our app, we have context on what the shape is, light and dark. And I'll go through one more example within the React library, like the useReducer hook. UseReducer is another function that allows it to manage states in a more refined manner. We specify the initial state in this example. It's simply the count property, which is a number. And then there's going to be a reducer function that takes it a little bit of a step further and allows us to dictate how we want state to change in a more specific manner. So if an action is being dispatched, we can dictate what's going to happen to our states. If anyone's ever used Redux, useReducer is a simple adaptation of that. So here is an example. We're saying if the action is of type increment, we increment the counts. If the action is of type decrement, we just decrease the counts. And in our components, we use the useReducer hook, pass in the reduce and initial state property, and we receive the state object and the dispatch function. This works, but again, without TypeScript, our component is unable to actually recognize what the shape of state or dispatch is. And TypeScript can give us an advantage here. We can describe the shape of state up front and say state is going to be a count of number, and we can describe the actions the component can take. It's either going to dispatch an increment type or a decrement type for the action. We make sure our reducer function is appropriately typed, and now with our useReducer function being used appropriately, anywhere in our component, the state property is going to be of the shape state, which above is defined as a count of number, and the dispatch function would recognize that's going to have one of two types. And this works just the same for custom hooks as well. As a very simple example, you would oftentimes create your own hook to fetch some information from an API or from the server. You can basically create, let's say, a useFetch hook. You pass in the URL where you want to fetch information, and the hook simply returns information that the component can use to render the UI, the data that's being fetched from the URL, the loading status of the request, and the error of if it was to occur during the request. If we're creating our own custom hooks, we take it a step further, and we define the shape of how our hook should behave. We can say perhaps that this particular hook should receive a URL of type string, but it will also receive a type variable denoted with the letter T. That type variable will be further passed to an interface we can create, and that type variable that can then be used to describe the shape of data that's going to be received from the server or from the URL. Similarly, we can also say the loading status may be Boolean, an error would be a string or null. Now, in our components, if we use this custom hook of ours, we can dictate the shape of data we expect from our URL, and we can just pass it into the useFetch declaration, just like we pass in the value of the actual endpoint that we want to hit. We get the data shaped appropriately within our component. Similarly, loading and error, we have the appropriate types for this in our component as well. Okay, so those were fairly straightforward. This particular section might be slightly more advanced, but I think it's super helpful when working within a React and TypeScript app. You might have noticed that when I was explaining type variables, I went pretty quickly. So I'm going to spend a bit more time going a bit slower here. Assume we have a function called the init function. This is in a normal JavaScript setting for now. It receives an argument and returns the argument. We now understand what TypeScript gives us. It allows us to specify the shapes of our parameters and our functions and what it returns. So we can take this a step further, and we can say the init function can receive a number, and it would return a number. Now, what if we wanted this function to be reused in different settings? Perhaps we want this function to be used for different data shapes. One straightforward way of achieving this is we can just simply use the union type. And we went through a few examples showing it, but it's essentially the pipe symbol that allows us to say in TypeScript that this function can receive perhaps a number or a string. And similarly, it can return a number or a string as well. This works. However, what if we wanted this function to be reused for numerous different data shapes? Some we may know now, but some we may not know in the future. It'd be a bit difficult having to come back and continuously specify the different shapes this function can receive. So a more hacky approach, we can perhaps say this function can receive any data, and it can return any data. And we're using the explicit any keyword TypeScript gives us that essentially removes the type safety and essentially says this component can just receive anything. It works, it's hacky, but we don't get any of the benefits that TypeScript provides. This is where type variables come in, or often known as generics. When you're actually defining the generic, you can use the angle bracket syntax, and we can say that this function is also going to receive a type variable. And then this type variable can then be used to specify the shape of the parameter and what the function returns. So here, in this context, we're saying this argument is going to be shaped whatever we pass in as a type variable. Similarly, this function is going to return the shape of data that's going to resemble the type variable or value we pass in. So if we use this function anywhere, we can actually now be explicit and say, now we're passing in a number and pass in a number. Now we're passing in a string and we pass in a string. Furthermore, now we can pass in anything else, an object that contains the key of fresh, that's going to be a string, and the value could resemble that. So that's the benefit of type variables and generics. It allows us to adapt our functionality for different data shapes while still adhering to the type safety TypeScript gives us. Now let's go back to React. Assume we were creating a component that we wanted to be reusable. It could be a simple data component or a data table component in this context. And we want this component to render a simple table of columns and rows. In our first instance, maybe we want to show user information that we want to fetch from the API. We can say data is going to be a list of those user objects, ID, name, email, and columns will simply be the keys of those objects, ID, name, and email. So if we were going to describe the shape of data being passed in here, we can just say user data is going to be a type that contains ID, name, and email, and the props of this component, data is going to be an array of those user objects, and columns would be an array of the keys of those user objects. It works, everything works well here, but as we mentioned, we want this data table component to be reusable. Maybe now we want it to be used for user data, but maybe we want to use it for product information. Perhaps there's somewhere else in our app where we fetch product data, and we feed in product IDs, product names. Or maybe somewhere else in our app, we want to basically have the same table render books. We fetch this information from an API, and we want this data table component to be adaptable. How can we have this one component receive these different data shapes? We could use the any keyword, as we mentioned earlier, but again, we remove any type safety that TypeScript gives us. We just say data can receive anything, and when we use this component, TypeScript is unable to tell us if we're doing something wrong or if there's any bugs or errors with how our types are shaped. So though this works, it's not ideal. We could use union types, as we mentioned earlier. We can specify 2 different shapes here, for example, the user object or a product object. And we can say the data and the columns of our components is going to be an array of those users or those products, similarly the keys of those users or those products. And then we can just simply have our component types with a manner like this. This works again, but it's not really maintainable if we expect this component to be reused with numerous different data shapes and us not knowing what those data shapes would be in the future. This is where generics and type variables come in. We can use the type variable syntax in the function component declaration itself. Notice the angled brackets right beside data table. We're saying this data table component can receive a type variable. Furthermore, it's going to be passed on to the props interface that receives a type variable as well. And the data prop and the columns prop of our component can use that type variable to essentially dictate the shape of what's being used or passed in for the component. So if we were using user data, we can just simply declare the shape of user data and pass it along to the data table components when we're actually passing in the appropriate data shapes. And this way, we're able to get the safety that TypeScript gives us. Similarly, we're also able to have this component be adaptable for many different use cases. I hope that was helpful. Okay, something that I, implicitly was doing or explicitly was doing was I was defining explicit types pretty much everywhere in all my examples. So when we were showing the use state hook, we were specifying that this function is going to receive a string with the type variable syntax. However, TypeScript is pretty smart. TypeScript can oftentimes infer what you're doing without us having to explicitly pass in type variables. So if we were doing this in a React component setting, we specify the useState function, pass in a string value of Hassan. We don't have to say that this is a string. It can be inferred. So name would be typed appropriately, and the setName function would expect a string as well. And this is the same for the data table or generic component example we were showing. Instead of having to explicitly pass in the user data shape, since React and TypeScript, or TypeScript can infer that this React component is a generic component, and its type variable is essentially denoted by the shape of data objects, just by doing this alone, TypeScript will be able to infer that the shape of data, or basically the shape of the T variable, would have an ID, name, and email in this example. However, there's going to be cases where we want to be explicit. For example, if we were defining an initial state property as like Hassan, which is a string, maybe elsewhere in our components we want to change it to null. TypeScript can't infer that for us, so we're explicit here and we say, hey, it's either going to be a string or it's going to be null, one or the other. Okay. I'm going to move on to another concept, which is pretty much common in any large TypeScript app, not necessarily just React, but it's helpful to understand if you've never used TypeScript before. When working within a large JavaScript application, be it React, we'd oftentimes install third-party libraries. And we do this because we don't necessarily want to do everything on our own, and we simply add these third-party libraries to make our application easier to use and maintain. For example, Lodash is a very common library that exists today. It's a library that contains a large number of utility functions to manage how we deal with arrays or objects. If we were to do this in a React and TypeScript app, and we simply imported a function from the Lodash library, attempted to use it to actually gain some information, let's say here as an example, we want to use the unique function from Lodash that allows us to create a unique array from a set of values within an array. If we were to do this in a React TypeScript app, we'd get an error. And the main error we would get is we can't find the module Lodash or its corresponding type declarations. Similarly, any variables we actually create or specify when using utilities from the library, we won't have any TypeScript shapes associated with it. And the main reason to this is because Lodash, in and of itself, is a JavaScript library. It doesn't have any type definitions associated with it. And this is where custom declarations is a concept that TypeScript gives us. We can create custom declaration files to describe the shape or the types of libraries that don't have types associated with them. And that can be done with the .d.ts extension. And then we can simply declare a module and then say, you know what? This particular library that we're using has a set of functions that we need in our app. Chunk, flatten, unique. It receives arrays and type variables. It also returns similarly type variable arrays, et cetera, et cetera. And this gives us what we're looking for. However, if we had to do this for every third-party JavaScript library we were using, things could be hard to maintain pretty quickly. This is where the definitely typed repository comes in. The repository for high-quality TypeScript type definitions, which is a community-run open-source library that contains a large number of type definitions for common third-party libraries. All we need to do is simply add the types from that library, the @types/library name. We add it as a development dependency. And in our components, whenever we actually use this functionality, we're good to go. TypeScript is able to recognize the shape of variables we're creating. So the common pattern that exists is if you're introducing a third-party JavaScript library, check the definitely typed repository first. If that doesn't exist, then you can create a custom declaration file in your app, specify it in your TypeScript configuration, and then you get what you're looking for. Okay. I recognize I have 5 minutes left, so I'll try to finish the next few slides quickly. The other concept that I found super helpful and super powerful, actually, when I first started working with TypeScript, is the ability to auto-generate types from APIs. When working within a large React application, you're going to be interacting with a server API. That API, perhaps, could be a GraphQL API. GraphQL, in and of itself, allows us to declare the shapes and the types of our API. So this could be the schema that represents how our GraphQL API is. And for this example, we can have a user object that exists somewhere in our server and database. And we can have a query and mutation to sort of query for that user and basically create that user. Queries and mutations are essentially how we request or make changes with the GraphQL API. So this exists in our server. If on our client, we wanted to actually make a request to that API, in a TypeScript setting, we probably want to specify the shapes of data we're working with. So in that user example, we can perhaps say we're creating or we're going to be getting user information. And similarly, this request that we're making is going to receive an ID of a particular user that we want to actually query for. And in some function that we have, be it use query, use fetch, we can maybe specify that it's going to receive type variables. And this allows us to ensure that our types are appropriately made in our user components. Now, we can already see where this can be an issue. Every single time we change our server API definitions, we're going to have to come back to our client app and also make changes to our client typing definitions. This is not maintainable, and it's going to take forever to get anything done. And this is where the concept to auto-generate types come in. Numerous third-party libraries exist that allow us to generate type definitions from our API code. For example, the more commonly used one for GraphQL is the GraphQL code generator. It allows us to generate code from our GraphQL schema. With a little bit of configuration, you run the autogen or the codegen command, GraphQL codegen, and by doing this, we're able to automatically generate TypeScript types from our GraphQL API. And in our React components, instead of having to describe the shapes on our own, all we need to do is import these shapes that have been auto-generated and use it where we need to. This works for GraphQL. What about REST APIs? This also works for REST. REST, in and of itself, isn't a typed API. It doesn't have types associated with it. So one common way of doing this is using OpenAPI, which is a specification that allows us to document how our REST API is described and shaped. Once we do this, we can then leverage generator tools like OpenAPI Generator to help auto-generate these TypeScript types based on our API. So when working within a REST setting, you go back to your API, you make changes to the shapes of your API, you just take the additional step to describe the shape of your API through documentation like this, most likely in a YAML file, and then you run the codegen command, and you're able to actually get the TypeScript types associated with it. Cool. So there's a few things we talked about today: typed props, React hooks, generic components, type inference, declaration files, Autogen API types. There's many more things one can do within a React and TypeScript app. I recognize that some of the things here might be, focused more on the simple side of things, but if you've never used TypeScript before, keep in mind there's a lot more you can do. One helpful resource that I use from time to time is this React TypeScript cheat sheets, which is a community-run cheat sheet that basically lists all the different capabilities that TypeScript provides within your React app. And that's pretty much the end of my presentation. One small plug, everything I talked about today is from a small chapter within a project I'm working on with a colleague of mine, hopefully to be done sometime in 2024. This is my socials. I hope this was helpful. Thank you all. Thank you so much.
Awesome job, awesome job. Care to join me for some questions?
Yes, absolutely. More than
All
happy.
right. So remember, hit up the QR code, ask any questions there. I'm getting them delivered directly to my phone. I'm looking at my phone for questions, not to be a jerk. And let's kick off with, I think, a nice spicy one.
Okay.
What is your argument against vanilla JS for the vanilla JS diehards?
The argument against.
Or the argument for TypeScript to a vanilla.
So my love for TypeScript is the fact that you can make it as strict as you want it to be, right? So if there's a level of looseness that you want with TypeScript, you're able to get some advantage of TypeScript while despite being able to deal with typings and whatnot. So oftentimes the argument I hear for vanilla JS is you move a lot faster, you don't have to necessarily worry about compilation process and steps. That is true, but I do feel like the advantages TypeScript provides is a lot more. And you're able to fine-tune the strictness of it for your use case or for your team's use case. So that would be my argument. It gives you a lot of benefits, and it gives you some customization capabilities. Yeah.
I tried to be a vanilla JS diehard, and then I realized that autocomplete was worth all the pain. Yeah. Like, I don't care about a lot of TypeScript, but I really care about autocomplete.
Absolutely.
So I have a question about in a large code base, right? What changes and what advice do you offer to somebody who's not starting greenfield but is trying to put TypeScript into an existing large code base?
Yeah, there's a few things I like to keep in mind. There are some other third-party tools that can help document your code. That could be a stepping stone, and one popular one is JSDoc. So if you're starting with a very vanilla, large-scale app, and you're trying to think about TypeScript, that could be a very simple step to just see how difficult it is to describe the shape of your code without necessarily installing TypeScript first. So that's something I think could help a little bit. A few other things I like to keep in mind is if you're introducing TypeScript, it has to be at a very incremental phase, or a very incremental set of steps. So the first goal is simply having the TypeScript tool set up in your app. Ideally having the compilation process running appropriately, having the checks being made in continuous integration, and then from then on you can devise a series of steps with your team. So perhaps you can decide to port over certain features or certain pages or certain components. So I'll say those are the first two things that come to mind. Consider using other tools like JSDoc if you're worried about how difficult it is to describe the shapes of your app. If you're feeling confident, install TypeScript, come up with a series of steps, and just do it from a, incremental process.
Yeah, so you touched on JSDoc just now, and there are a lot of upvoted questions around this. So with the extra compilation step of TypeScript, that can add extra time, extra complexity, et cetera. Do you think that JSDoc can be a complete solution? Or you mentioned it as a stepping stone.
Yeah, it could be, to be honest, and I think it comes down to what you're looking for, right? TypeScript does have a lot of capabilities to it, and I think the key aspect of TypeScript that I love the most is how strict you can make it, right? If you feel like, I don't need to deal with all of this, I don't need to worry about this level of detail and compilation and whatnot, all I want is a method to just document the shapes of my code and be able to quickly just understand it by being able to read my code, JSDoc could be a complete solution. So I'm not the kind of person to say TypeScript is the end-all, be-all. I am a big fan of TypeScript, but I think JSDoc can satisfy you depending on your use case.
So in that vein, when it comes to TypeScript, what are some best practices that you feel like you're not seeing enough of, that you'd like to see more devs incorporate into their code base?
Yeah. I think, yeah, even in the current code base that I'm working with today, I think one thing we've just noticed, literally yesterday I was dealing with some of my colleagues on, is just a level of agreements on how strict you want to make TypeScript be. So I think that's sometimes something that I tend to have some difficulty with. You know, you're working on something, you're dealing with something well, and then you get a ping by one of your friends or colleagues and say, why is this the case with TypeScript? Why do we have to, you know, enforce how, you know, functions are being returned? Or why are we enforcing this particular shape or type or this rule? So I think sometimes there's a little back and forth that I feel like tends to happen when working with multiple other people in a TypeScript app. So that's one thing that comes to my mind. Another thing that comes to my mind is we noticed this in the app we were working in with myself and my colleagues. Though our local development environment was catching some TypeScript warnings appropriately, our pipeline for how we ship code wasn't catching a lot of those warnings. So that's something to keep in mind, right? Not only are we making our development environment easier and more maintainable, we want to make sure we're pushing code that satisfies all the TypeScript rulings we have. Because if that isn't being done, it leads to a large maintenance effort later on where you have to come back and make sure that everything works well. So make sure your CI works just the same as your local dev environment. Yeah, that's what I'll say for that.
That's real.
Yeah, it is real. It is real. Absolutely.
So I have a question about the sort of the spectrum of what you can learn, right? Like obviously TypeScript is a deep well, and you can go far in it.
Yeah.
For somebody who is a product engineer, how much TypeScript do you need to learn? Like where do you, you know, can you never learn generics and still be effective? Or, you know, where do you draw that line?
Yeah, I love that question, to be honest, because I think, as mentioned, there's some complicated concepts in TypeScript, and I think generics is one of them, where if you look at the code, you're like, what is going on here? I genuinely feel that with a very little bit of TypeScript, you can go a long way. Just by being able to type your functions, your parameters, in the context of components, your props, and you know, simple things like some of the things we discussed today, you're able to get a lot of benefit for very little effort, to be honest, right? You're just adding a few little bits of code, and you're able to go very far. So if you want to go further, that's doable. But I generally hold the opinion that with a very little bit of TypeScript, you're able to get a lot of advantages.
I have found the same in my work, is that there's sort of diminishing returns, especially if you're not like an internal tools person.
Absolutely, 100%. And one other thing I'll add to that, actually, there would be times where you're dealing with just some really messy TypeScript code, and I do feel like sometimes you have to weigh the pros and cons of spending forever dealing with this, or, you know what, saying, for now, I'm actually going to remove any static typing with this component and come back to it later. So like you said, there's diminishing returns for sometimes how much effort you put in or how much, you know, of a deep dive you do in, and it's up to you to figure out where it's beneficial.
Yeah. So social media is you know, we all know that social media is a bubble, but when you read social media, it makes it sound like TypeScript has completely taken over, and like there's nothing written today that's not in TypeScript. Now, I know that's not practically true, but I don't know how, like, to what extent. You've worked in a lot of large companies with big teams and big products. In your experience, how broad is the adoption of TypeScript in these larger companies?
Yeah, in my experience, I do think the adoption is there. Like, I do think a lot of the big name companies you hear of, they are using TypeScript to a certain extent. Despite that, though, you make a good point, right? There's thousands and thousands of teams and companies, and I know for a fact that many of them don't need TypeScript. They don't feel like they need TypeScript, and that's valid as well. I do know there was a tweet by somewhat prolific in the tech industry who's completely removing TypeScript from an open source library that he was using. That caused a bit of a murmur in the social media space. Again, I hold the opinion that it works for some people. It doesn't work for everyone. However, I do feel like if the application gets to a point that it starts to become somewhat difficult to maintain, and you just recognize that, oh, this is a large app, TypeScript becomes a big help.
Yeah, I mean, code is communication, right? And the tools that we use to communicate with our coworkers, as long as we're actually communicating, we're
That's
getting a benefit.
exactly the point. Exactly.
Yeah.
Exactly. 100%.
Okay, so let's see. Are there any areas where TypeScript can make React Dev more limiting or difficult?
Yeah. I think the biggest issue that I've noticed that sometimes makes React a bit difficult to use isn't necessarily, I know this might sound weird, but not necessarily the components or types my team and I create. It's oftentimes using a third-party library or tool that either has its own types associated with it, or doesn't have types, and you're installing these third-party types indefinitely typed, or you're creating custom declaration files. I think that's where the limiting factor comes in. Because oftentimes you install something from somewhere else, they have their own shapes or types associated with it. You try to use it, and sometimes you get a bit confused. You say, wait a minute, why is it expect data in this shape, or why isn't this working? So I think that's been, the biggest limiting factor, and that's where I think I spend most of my time dealing with, I guess, a little bit of messiness.
Upvoted question here on configuring TypeScript. So have a hard time configuring TypeScript with stuff, especially when it's working with something like Jest. Do you know of any good resources or tips for figuring out how to get that to work properly?
Yeah, nothing comes to mind for like any tips out there. To be honest, I find that also sometimes difficult, depending on the external tools you're using. So if you're using many different libraries for testing and whatnot, you may have to go and take things step by step. Something that my team and I do, we try to basically isolate whatever issue we're dealing with. And sometimes if the issue remains for a long period of time, let's say Jest, and we're just unable to configure any form of shape, we sometimes even take a step back and say, is this an issue where we should be either going back to a lower version of this, or are we updating this version completely, or are we doing a revamp, or should we consider even another testing suite? It can come to that point. But yeah, that's my best bit of advice. Just try to isolate what the issue is, be it Jest or be it how TypeScript is working with something else, and just try to narrow down what you can do.
So this is a follow-up on I think, the how much TypeScript do you need to learn. How important is it for somebody who's new to web dev to learn TypeScript?
Good question. I don't necessarily think it's super important. If you're brand new, don't worry about TypeScript first. I'll just say start using JavaScript, understand what JavaScript does properly. Once you start using some of these third-party libraries like React, Angular, whatnot, recognize what these libraries are doing as well, because those are stepping stones in your learning process. Once you feel comfortable, then I would hold the opinion, consider looking into TypeScript. And not necessarily what TypeScript does, because I think that's the easy part, but like some of the questions brought up, the compilation process, how you deal with third-party libraries. There's a lot of sometimes, I guess, tertiary things you need to learn. And if you're learning web development for the first time, I don't think it's super important, in my opinion. Yeah.
So I'm looking at the questions, and I just learned a phrase that I've never heard before, and maybe you've heard this. What's your opinion on type-driven development?
I've seen that term being used. I haven't really seen it used in practice, though, from what I understand what it means. I guess type-driven development, drive your development with types first. A lot of the work that I tend to do is, user-facing or product-facing. So even the terminology test-driven development isn't something I tend to see as well. So despite that being a much more commonly understood terminology, I guess I don't know. I actually don't know exactly what it entails. My perspective is a lot of the work that I tend to do isn't necessarily TypeScript first. It's sort of what is the feature we're building, how are we building it, what are the tools we're using to build it, are we using some of the component libraries that exist in the company, are we using third-party libraries, and then do we consider, okay, how do we describe the shapes of what we're doing, and how do we do that for other tools we use in our process.
Yeah. I have definitely found that like test-driven development and type-driven development, anything like that, is one of those things that everybody talks about it, and I've never met anybody who does it.
Likewise. Likewise. I fully agree with that notion. Yeah.
So in TypeScript, you can set the config to varying levels of strictness. Have you found that going to strictest has benefits? Like, do you think it's worth the effort?
I don't, personally. And I think it comes down to the point that we just discussed, not because of the way we write our own code, it gets a bit annoying or difficult once we start using third-party libraries or tools. So my sweet spot is making it almost all the way there with some caveats. and then having it at that level of strictness. So I would say 70% of the way there. That's the sweet spot myself and my teams have found that work well. Yeah.
I like that.
Thank you. Thank you.
At what point in the development process, like, where's your internal limit where you go, you know what, just mark it any?
Funny enough, yesterday, no joke, 6 p.m. No joke.
So it's not actually a complaint, it's a time issue.
Exactly.
It's dinner time, mark it any, ship it.
100%, 100%. So it's literally my colleagues and I are on a Zoom call, and we're trying to figure something out, and our goal was to update our React version, but that caused a bunch of TypeScript issues, and then it got to a point, you know what, here, mark it any, we're calling it a day, we'll come back later. Though, to be fair, we don't usually come back right away, but we'll come back at some point.
No, I love that. That's, I mean, I think that's the healthy approach, right?
Exactly.
There's a point where you're code golfing with TypeScript, and it's like, it's fun to solve that puzzle, but is it useful?
Exactly, or what's the end goal? Exactly.
Yeah. Okay. Ooh, code standards, right? So TypeScript is good for enforcing consistency through a code base and making sure that you're not accidentally making mistakes. What else are you using in your code bases in terms of tools to kind of help enforce some of those standards?
Definitely. linting is 100% important. And oftentimes it will work with TypeScript to get whatever linting rules you like. Linting is basically the process of ensuring your code is formatted or set up in a way that you're all in agreements on. In terms of just general, spacing, formatting, using a tool like Prettier is the get-go. So Prettier, ESLint, TypeScript, that's sort of like the trifecta when dealing with these three tools. And then I'll take it a step further. I'm a big advocate of documentation. Having those documents set up between you and your team, any gray areas of how things should be done, making sure that you and your team align on it. I don't necessarily think that's a must from the get-go, but it's super important to have this set of standards documented as well as set up with tools that help make your development process easier and better. Yeah.
Well, we have a whole bunch more questions, but unfortunately we don't have any more time. So, y'all, if you didn't get your question answered, make sure you look for Hassan out at the mixer or in the breaks. Thank you so much.
Thank you.
Another round of applause for Hassan.
Thank you all. Thank you so much.
And with that, we are going to take another 15-minute break while we get ready for the next speaker. We will see you back here at the top of the hour. Thanks, y'all.